The end behavior of a polynomial function depends on the degree, and the degree can be either even or odd, and it also depends on the leading coefficient. And the leading coefficient can be positive or negative. So there are 4 types of end behavior. So if we have an even degree and a positive leading coefficient, which is our first graphic box here, as x approaches infinity, f of x also approaches infinity. That's this end right here. As x approaches negative infinity, f of x approaches positive infinity. That's the left end there. So there's an example, g of x, of an even function with a positive leading coefficient. Then we have even degree and negative leading coefficient. So a negative leading coefficient for a parabola-shaped curve just flips it upside down, right? That's a reflection over the x-axis. So as x approaches positive infinity, f of x approaches negative infinity. Also, as x approaches negative infinity, f of x will also approach negative infinity. So h of x is an example where we have an even degree function with a negative leading coefficient. So we have both values of the function on both ends approaching negative infinity. Now let's look at odd degree options. We have an odd degree with a positive leading coefficient. So as x approaches positive infinity, f of x will also approach positive infinity. So the right end goes upwards. As x approaches negative infinity, f of x approaches negative infinity. So the left end goes downwards. So s of x on the right is an odd degree of 7 with a leading coefficient of positive 0.1, and it shows that the end behavior is that of an odd degree and a positive leading coefficient end behavior. And then finally we have an odd degree with a negative leading coefficient. So that just takes what we just saw and gives it a flip over the x-axis. So as x approaches positive infinity, f of x is going to head towards negative infinity. As x approaches negative infinity, f of x will approach positive infinity. So t of x to the right has a negative leading coefficient and an odd degree, and its end behavior matches that which we have in the box on the left.